Okay, hi everyone, welcome back to this video live series discussion on Windows Server 2000. So let me just share my screen here. Okay, so chapter 17, migration strategies and upgrades, planning for the transition from Windows 2000 Server. As organizations grow and technology evolves, the need for modern, more secure and efficient systems becomes paramount. Windows 2000 Server, once a powerful and widely adopted platform, has long since reached its end of life, leaving it vulnerable to security threats and performance limitations. However, many organizations continue to rely on Windows 2000 due to legacy applications, hardware dependencies, or operational continuity concerns. This chapter will explore migration strategies and upgrade paths to help organizations transition um, from Windows 2000 to more modern platforms such as Windows Server 2003, Windows Server 2008, or beyond. We will cover key considerations, steps for a successful migration, and how to ensure minimal downtime and disruption during the upgrade phase. Or sorry, the upgrade process, I mean. So 17.1, the need for migration. Windows 2000 Server, although once revolutionary, no longer meets the needs of modern enterprises. The lack of security updates and compatibility with current hardware and software creates risks that organizations can no longer afford to ignore. Below are some key reasons why upgrading or migration is necessary. One, end of support. Microsoft officially ended support for Windows 2000 Server in 2010. This means no more patches, security updates, or technical support, leaving systems vulnerable to evolving threats. Running unsupported systems can expose your organization to data breaches, malware, and other security risks. Two, security vulnerabilities. The security landscape has changed significantly since the release of Windows 2000. Modern operating systems have better security features, such as enhanced security, integrated firewalls, and more advanced access control mechanisms. Without these, Windows 2000 servers are susceptible to security breaches. Three, software and hardware incompatibility. Windows 2000 Server is increasingly incompatible with modern hardware and software. Newer applications and operating systems may not run on a Windows 2000 environment, making it difficult to adopt new technologies and improve business process. For performance and scalability, Windows 2000 is limited in terms of performance and scalability, especially for organizations looking to grow and support more users, application, or virtualized environments. Newer versions of Windows Server support enhanced virtualization, better memory management, and improved CPU utilization. Uh, 17.2, key considerations before migration. Migrating from Windows 2000 Server is not a simple task. A successful migration requires careful planning, resource allocation, and a thorough understanding of the existing infrastructure. Here are key considerations to make before embarking on your migration journey. One, inventory and assessment. Start by performing a detailed inventory of your current environment, including servers. List all servers running Windows 2000 and their respective roles, e.g., domain controllers, file servers, application servers. Applications. Identify all the applications running on Windows 2000, including any legacy software that may need to be replaced or upgraded. Hardware compatibility. Check if existing hardware is compatible with the new version of Windows Server or if hardware upgrades are necessary. Data access. Access the data stored on Windows 2000 servers and identify what needs to be migrated to the new system. 2. Choosing the target platform. Next, determine which version of Windows Server is best suited for your organization's needs. Microsoft has released several versions of Windows Server since 2000, each with new features and improvements. Key options include Windows Server 2003, a logical upgrade path for many Windows 2000 users, while still outdated, it offers a better security model and more robust feature than Windows 2000 Server. Windows Server 2008, a more modern and secure option that introduces the new server core, Hyper-V virtualization, and better integration with Active Directory. Windows Server 2012, 2016, 2019, the latest versions offering cutting-edge features like enhanced security, virtualization, cloud compatibility, and support for containers. While most future-proof, the migration to these versions requires a significant infrastructure upgrade. 3. Data and application compatibility. Ensure that critical data and applications are compatible with the new operating system. Some legacy applications may not run on newer versions of Windows Server, necessitating updates or replacements. Perform testing in a sandbox environment before migrating production systems to identify potential issues with software compatibility. 4. Downtime and business continuity. Consider the impact of downtime during migration. Determine the best migration strategy to minimize disruption to business operations. Depending on the size and complexity of your environment, this could involve staged migrations, weekend upgrades, or leveraging virtualization to transition without prolonged downtime. 17.3 Migration strategies. There are several migration strategies you can use to move from Windows 2000 Server to a newer version. The most appropriate strategy depends on your specific organizational needs, existing infrastructure, and the level of risk you're willing to accept. 1. In-place upgrade. An in-place upgrade involves upgrading the existing Windows 2000 server directly to a newer version of Windows Server. This strategy is typically the fastest, but it carries certain risks. Pros: minimal hardware requirements, preserves most configurations, users, and applications. Cons: there may be compatibility issues with some older software. The upgrade process can result in extended downtime. Some settings and configurations may not transfer smoothly. How to perform an in-place upgrade. Ensure that all data is backed up before beginning the upgrade. Verify the hardware and software compatibility with the new operating system. Use the installation media for the new version of Windows Server and perform the upgrade by running the setup from within Windows 2000. During the upgrade process, ensure that you follow all instructions carefully and monitor for errors. After the upgrade, verify all services, applications, and users are working as expected. 2. Parallel installation. A parallel installation involves setting up a new server running the new version of Windows Server alongside the existing Windows 2000 system. Once the new server is configured, you can migrate data, applications, and users over to the new environment. Pros: lower risk of data loss or system corruption, allows testing for the new environment before fully switching over, minimal downtime during the migration process. Cons: requires additional hardware, involves more time and resources to configure the new server and transfer data. How to perform a parallel installation. Set up a new server with the target version of Windows Server. Install and configure necessary applications and services. Test the new server thoroughly before migration. Transfer data and migrate user accounts and groups. Once everything is functioning properly on the new server, decommission the old Windows 2000 server. Migration via virtualization. In some cases, it may be beneficial to first virtualize the Windows 2000 server and then migrate it to a newer platform. This approach allows you to preserve the legacy environment while upgrading to a more modern infrastructure. Pros: minimal downtime during the migration process, easier to scale and manage. Virtualized environments can provide greater flexibility and disaster recovery options. Cons: virtualization adds complexity to the migration process, requires robust hardware for hosting the virtualized environment. How to migrate via virtualization. Use a virtualization platform such as VMware or Hyper-V to create a virtual machine for the Windows 2000 server. Perform the migration within the virtualized environment to test compatibility with newer versions of Windows Server. Once testing is complete, migrate the virtual machine to a more modern Windows Server version. 17.4 Post-migration considerations. After migrating from Windows 2000 Server to a newer version of Windows Server, it is important to validate that the new environment is fully operational and secure. Post-migration activities include 1. Testing. Functionality testing. Ensure that all application services and user accounts are functioning properly. Security testing. Verify that the new server environment is properly secured and up to date. Patches, strong passwords, and appropriate access controls. Performance testing. Monitor the performance of the new server environment to ensure it meets expectations in terms of speed, scalability, and resource utilization. 2. Backup and disaster recovery. Once the new environment is fully operational, implement a robust backup and disaster recovery plan. Ensure that you are regularly backing up critical data, system configurations, and applications. 3. Training and documentation. Ensure that your IT staff is well trained on the new system and that proper documentation is in place for ongoing support. This will help ensure smooth operations and quicker troubleshooting in the future. 17.5 Summary. Migrating from Windows 2000 Server to a newer version of Windows Server is a significant but necessary step for any organization looking to maintain a secure, efficient, and scalable IT environment. While the migration process can be complex, a well-planned and executed migration strategy, whether it involves in-place upgrades, parallel installations, or virtualization, can ensure a smooth transition with minimal downtime and disruption. Before migrating, it is essential to assess your current infrastructure, choose the right target platform, and thoroughly test your migration plan. Post-migration, ensure your system is secure, backed up, and properly documented to avoid potential issues in the future. In the next chapter, we'll explore cloud integration and hybrid environments, focusing on how to leverage modern cloud services alongside traditional server infrastructure. So, Chapter 18, Cloud Integration, Hybrid Environments, Embracing Modern Technologies while Maintaining Legacy Systems. And as organizations migrate from legacy systems like Windows 2000 Server, one of the key considerations is how to integrate modern cloud services into the IT infrastructure. The adoption of cloud computing is no longer a trend but a business necessity. Cloud services offer scalable, flexible, and cost-effective solutions that can complement or replace traditional on-premise infrastructure. However, organizations that have been running Windows 2000 Server or older versions may still rely on legacy applications, on-premise servers, and traditional IT models. Transitioning to the cloud doesn't mean disregarding these legacy systems entirely. Many businesses are now adopting a hybrid IT environment which combines both on-premise infrastructure and cloud-based services. This chapter, we will explore how organizations can effectively integrate cloud services into their existing Windows Server environment and build hybrid infrastructures that support both legacy and modern applications. We'll cover key cloud concepts, integration strategies, and the benefits of hybrid environments for business undergoing digital transformation. So 18.1, understanding cloud computing. Before diving into cloud integration, it's important to understand the basic concepts of cloud computing and the different types of cloud environments available. What is cloud computing? Cloud computing refers to the delivery of computing services such as servers, storage, databases, networking, software, and analytics over the internet or the cloud. Cloud providers manage the infrastructure, allowing businesses to access and scale resources without the need to own or maintain physical hardware. Key cloud models. 1. Public cloud. Services are delivered by third-party providers and shared among multiple customers, tenants. Examples include Amazon Web Services, AWS, Microsoft Azure, and Google Cloud. Private cloud. The cloud infrastructure is dedicated to a single organization, either hosted on-premise or by a third-party provider. It provides more control over data and security. Hybrid cloud. A combination of public and private clouds allowing data and applications to be shared between them. This model enables businesses to take advantage of cloud flexibility while retaining on-premises cloud control where needed. Key cloud service models. 1. Infrastructure as a service provides virtualized computing resources over the internet. Examples include virtual machines, VMs, storage, and networking. Microsoft Azure and AWS offer IaaS solutions. Platform as a service, PaaS, provides a platform allowing customers to develop, run, and manage applications without worrying about the underlying infrastructure. Azure App Service is an example. Software as a service, SaaS, delivers software applications over the internet on a subscription basis. Examples include Office 365, Salesforce, and Google Workspace. 18.2 Hybrid IT environments, benefits and challenges. A hybrid IT environment is one that incorporates both traditional on-premises infrastructure and cloud-based services. This approach allows businesses to leverage the advantage of the cloud while maintaining control over critical workloads and sensitive data on-premise. Benefits of hybrid environments. 1. Flexibility and scalability. Hybrid environments allow business to scale workloads as needed. Cloud resources can be added to meet increased demand, while on-premise systems continue to handle more stable workloads. 2. Cost efficiency. Businesses can move less critical workloads to the cloud to take advantage of the pay-as-you-go model while keeping core systems on-premise to avoid unnecessary costs. 3. Improved disaster recovery. Storing backups and critical data in the cloud ensures that in case of disaster, recovery can be quick and efficient. Cloud services also provide automated backup and replication, improving business continuity. Enhanced security and compliance. Sensitive data can be retained on-premise or in private clouds, while organizations have more control over security policies. At the same time, non-sensitive workloads can be moved to the public cloud. 5. Legacy system integration. Legacy systems such as Windows 2000 Server can be integrated into a hybrid environment, allowing for gradual migration to cloud-based platforms without disrupting ongoing interruptions. Challenges to hybrid environments. 1. Complexity. Managing both on-premise infrastructure and cloud-based resources requires a sophisticated IT strategy and skill set. Ensuring compatibility and seamless integration can be challenging. Two, security concerns. While cloud providers typically offer robust security measures, businesses must take care to configure their hybrid environments to avoid vulnerabilities that may arise while connecting on-premise systems with the cloud. Data integration. Migrating data between on-premise systems and cloud services can be complex, particularly for legacy systems. Businesses may need specialized tools to facilitate smooth data transfer. Cost management. All hybrid environments offer cost flexibility. Tracking and managing costs across both on-premises and cloud infrastructures can become complex, especially as cloud resources scale up. 18.3 Cloud integration strategies for legacy systems. For organizations running legacy systems like Windows 2000 Server, migrating it to the cloud can seem daunting. However, cloud integration is not an all or nothing proposition. Below are several strategies for integrating cloud services into your existing IT environment while maintaining legacy systems. One, lift and shift migration. The lift and shift strategy involves moving existing applications and data to the cloud with minimal changes. This is the fastest migration approach and works well for non-critical applications or systems that don't require frequent updates. How it works. Identify workloads that can be moved to the cloud without modification. Use IaaS services such as Amazon EC2 or Azure virtual machines to create virtual servers in the cloud. Migrate the data and applications as is to the cloud, allowing them to run in a virtualized environment. Benefits. Quick and cost-effective migration path. No need for re-architecting legacy systems. Challenges. Performance may not improve and there may be limitations on optimizing cloud resources. A cloud may not fully integrate with on-premise systems, leading to fragmented environments. Two, a hybrid cloud with virtualization. For businesses that need to keep some systems on-premise, a hybrid cloud environment can be used in conjunction with virtualization. Virtualization allows business to run legacy applications in virtual machines, VM, or modern hardware, bridging the gap between legacy infrastructure and cloud platforms. How it works. Virtualize legacy systems such as Windows 2000 by running them as VMs in a hypervisor environment. Use tools like VMware, vSphere, and Microsoft Hyper-V to virtualize both on-premises and cloud-based resources. Connect on-premise VMs with cloud-based services, enabling hybrid workloads and data transfer between systems. Benefits. Virtualization allows organizations to modernize infrastructure while still supporting legacy applications. Cloud resources can be used to scale workloads while legacy systems can be maintained in a virtualized environment. Challenges. Virtualizing legacy systems may not always be feasible or efficient, especially if the applications rely on older hardware or operating system features. Managing a hybrid cloud environment requires skilled IT resources and careful planning. Three, cloud storage and backup. If migrating entire workloads to the cloud is not feasible, another approach is to integrate cloud storage and backup solutions into the existing infrastructure. Cloud storage offers scalable and cost-effective solutions for storing data, while backup solutions provide enhanced disaster recovery. How it works. Use cloud storage solutions like Amazon E3, Azure Blob Storage to store data that doesn't require frequent access or backup or to back up critical data, set up automated backup process to ensure that on-premise data is regularly backed up to the cloud, implement disaster recovery solutions to replicate on-premise data and systems to the cloud for quick restoration in case of failure. Benefits: minimal impact on existing systems, with cloud storage simply acting as an extension of on-premise storage. Enhanced disaster recovery capabilities with cloud-based backups and rapid restoration options. Challenges: integration between on-premise systems and cloud storage requires proper configuration and network setup. Data transfer costs can increase with large environments of data of or frequent backup operations. Cloud-based applications and SaaS integration. Many organizations rely on legacy systems. Integrating cloud-based applications can offer immediate benefits, particularly in areas like collaboration, productivity, and CRM. CRM, it means customer relationship management. How it works: adopt software as a service, SaaS solutions such as Office 365, Salesforce, or Google Workspace to replace legacy desktop applications or on-premise software. Integrate these cloud-based applications with existing systems to streamline workflows, improve data accessibility, and enhance collaboration. Use APIs and other integration tools to connect cloud-based applications with on-premise infrastructure. Benefits: immediate access to modern applications with minimal disruption, improved productivity, collaboration, and scalability, reduced reliance on outdated software and hardware. Challenges: ensuring compatibility and secure data transfer between legacy systems and cloud applications, employee training and adjustment to new cloud-based software tools. 18.4 Best practice for cloud integration. To successfully integrate cloud services into your hybrid environment, follow these best practices. Start small and scale gradually. Begin your migrating non-critical workloads to the cloud, allowing your team to gain experience with cloud management. As you become more comfortable, scale up your cloud adoption to include more mission-critical systems. Maintain security and compliance. Ensure that cloud integrations follow industry-specific security and compliance standards. Use encryption, multi-factor authentication, and access controls to secure your cloud-based and on-premise resources. Monitor and optimize. Use cloud management tools and monitoring solutions to track the performance, cost, and resource usage of your hybrid environment. Continuously optimize resource allocation to avoid unnecessary expenses. Test before migration. Thoroughly test cloud integrations in a staging environment to ensure smooth performance before moving production systems to the cloud. 18.5 Conclusion. Integrating cloud services into a legacy environment can significantly enhance operational efficiency, scalability, and disaster recovery capabilities. By adopting a hybrid approach, businesses can leverage the benefits of both traditional on-premise infrastructure and modern cloud technologies, providing the best of both worlds. Migration to the cloud doesn't require abandoning legacy systems entirely. With careful planning and the right strategies, you can gradually modernize your IT environment while maintaining the stability and functionality of your existing infrastructure. As cloud technologies continue to evolve, hybrid environments will play an increasingly crucial role in shaping the future of IT enterprise. In the next chapter, we'll explore emerging trends in IT infrastructure. So I'm going to leave it here today for this live stream. Thanks for spending the time with me. Hope you enjoyed listening and have a good day.